Hello and welcome to the video on polygons. By the end of this video, you should be able to tell me if an object is a polygon or not. And if it is a polygon, you should be able to describe it as convex or concave, as well as regular or irregular. Let's start with what a polygon is. First of all, a polygon is a closed figure. So an example of something that is not a polygon would be something that looks like this. It is most definitely not closed. Second criteria to be a polygon, it has to be made up of 3 or more line segments. So another example of something that would not be made of 3 or more line segments and therefore not a polygon would be, let's say a semicircle. There's one line segment. That thing right there is most definitely not a line segment. Therefore this thing is not a polygon. And the last criteria here, it has to be connected only at their endpoints. So another example of something that would not be a polygon would be this object here. If I have one line segment followed by a second and a third and a fourth, that object is not a polygon. In reality, it's 2 polygons. The top part here would be a triangle when I fill it in, and the bottom part here would be a triangle, but together that's not a 4-sided polygon. Let me draw a few things here that are polygons. I could have a 4-sided polygon or a 7-sided polygon. Either way, those are completely closed off. They are made only of line segments and they are connected only at their endpoints. Once we know what a polygon is, we should also be able to name a polygon. Polygons are just named by the number of sides that they have. Some of these names I am very confident you have heard before. Some of them may be new to you here. Let's work our way through. Some of the ones I'm pretty sure you probably know is a 3-sided polygon. Well, that's just a triangle. 4-sided polygon is a quadrilateral. A 5-sided polygon is a pentagon. If a polygon has 6 sides, that's a hexagon. 7-sided polygon is a heptagon. 8-sided polygon is an octagon. A 9-sided polygon is a nonagon. 10-sided is a decagon. An 11-sided polygon is called a hendecagon. And a 12-sided polygon is a dodecagon. Anything else we're just going to call by its number. So an n-sided polygon would be an n-gon. And what I mean by that is if I had a 37-sided object, I would just call it a 37-gon. It really does have a name, but for today, we're not going to bother learning the names of every single number of polygons, so anything over 12, just use its number. Once we know something is a polygon, we can decide whether or not it is convex or concave. These are mutually exclusive events. That means that every polygon is one of these 2 things. There's nothing that can be both convex and concave, and there's nothing that can be neither convex nor concave. To be a convex polygon, I would need to be able to extend each of those line segments that make up the polygon. And when I extend those line segments, I would have to make sure that they do not enter into the interior of the polygon. What I mean by that is this. Let's start with this first object here, my 4-sided polygon. If I would take each of the line segments that make up that polygon and I would extend them out, make those line segments into full-blown lines, I notice here that each of these lines now does not go into the middle of the figure. If I try that same thing with the second polygon, when I extend each of these line segments and make them into lines, you will notice that some of those, for example, these next 2 I'm about to draw here, would go right through the middle of the figure. So because each of those 2 segments here goes right into the middle, this is something that is not convex. If something is not convex, then it would be concave. So to recap here, this first one, because each of these lines did not enter into the polygon, this thing was convex. And with my second figure here, because the lines did go into the middle of the polygon, this thing is concave. A few more terms. We've seen these next two terms when we talked about triangles, but really it works for any polygon. A polygon can be equilateral if all of its sides are the same length. So a polygon in which all sides are congruent. An example of something that is equilateral would be a rhombus. Each of these sides are congruent to each other, so that would make it an equilateral polygon. An equiangular polygon is exactly what it sounds like. It has equal angles. So it's a polygon in which all of its angles are congruent. An example of an equiangular polygon would be a rectangle. A rectangle has all congruent angles. In this case, they're all 90 degrees. Because all those angles are congruent, that polygon would be equiangular. Well, that brings us to our next two definitions here. Once I know something is a polygon, I can tell whether it is regular or irregular. Again, these are mutually exclusive events. It's got to be one of the two. A regular polygon is just a polygon that is both equilateral and equiangular. An example of a polygon that is regular would be a square. A square is a four-sided object. All of its sides are congruent, so it's equilateral, and all of its angles are congruent, so it is equiangular. There are plenty of other objects that are regular as well. They're a little bit harder to draw here, but you could have a hexagon, for example, or an octagon. That would be regular as well. I'm going to attempt to draw one here, but humor me and pretend those are all congruent to each other, and all the angles are congruent as well. So if that were the case, this thing would be regular. And our last definition here, irregular. Well, because I said they were mutually exclusive events, if it's irregular, that all that means is that it is not regular. Let's try a few examples, see if we really do understand what this means. For each of these 6 examples, I want to determine whether the object is a polygon. If it is a polygon, I want to name the polygon by its number of sides. Then I want to classify the polygon as concave or convex, and regular or irregular. Problem number 1. While looking at this, I notice it is not made out of line segments. This object right here is most definitely an arc. So I can right off the bat say that this is not a polygon, and move on to problem number 2. Problem number 2, I notice, is made up of completely lined segments. They are connected only at their endpoints, and this object is completely closed. So this thing is a polygon. To figure out what kind of polygon it is, I would just add up the sides. I have 1, 2, 3, 4, 5, 6, 7, 8 line segments, which would make this an octagon. Once I know it is an octagon, I need to decide whether it's convex or concave. Well, this particular object, if I extend these line segments out, you'll notice how it goes right through the middle of the figure here. And that means it's concave. And whether it's regular or irregular. Well, this is actually kind of a tricky one here. A lot of people, when they look at this, will say, hey, all those segments are the same length. That's going to make it regular. Well, even if all these segments here were the same length, that still doesn't make them regular. Remember, to be regular, it has to be both equilateral and equiangular. And if we look at these angles, you'll note that this angle right here and that angle right there are nowhere near the same size, which tells me that this is irregular. Problem number 3, well, this one's marked for us. All the angles are congruent to each other. All the sides are congruent. So without even knowing how many sides it has, I know that this thing is regular. If I go back and count how many sides it has, I see it has 5, which makes it a pentagon. And whether it was convex or concave, well, if I would extend any of these lines out, you'll notice how it does not go into the middle of the figure, and that is going to make it convex. Continuing along, problem number 4, that thing's got a lot of sides. If I start counting them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. I notice this one has. That is a dodecagon. If I would extend any of those line segments, they would not go into the middle of the figure, so it is convex. And those sides look like they're not the same length. If I take a look a little more carefully here at these segments, you can tell here that that length right there and this one right here are most definitely not the same size. So I would say that this is irregular. Continuing along with problem number 5, I again just need to count up how many sides it has. I see 1, 2, 3, 4, 5, 6, 7 sides. That would make this a heptagon. When I extend the line segments out, it most definitely goes through the middle of the figure, so it's concave. And not all the sides are the same length. This is now irregular again. And the last one, problem number 6, when I look at this, I notice it is not completely closed. So this is also not a polygon. Which brings us to the conclusion of our video. I hope you have a wonderful day.